In this videotape, we're going to be reviewing our work with fractions. Okay, this is a review tape on fractions. If you find that we're going too fast in any part of this tape, you can go back to the original videotape lessons involving fractions. In the first example, we would like to reduce to lowest terms the following. 2x squared minus 6x over x squared minus 6x plus 9. And by now you're aware of the fact that, for example, you cannot cancel out the 6x's. These are terms. They are not factors in the numerator and the denominator. The idea is to factor completely the numerator and the denominator, and then we may cancel out factors in common. Remember, the fundamental principle of fraction says that if you have a fraction, say a over b, we will get an equivalent fraction if we multiply the numerator and denominator by the same non-zero quantity. And working the other way, if we have a fraction, say ak over bk, we will get an equivalent fraction if we divide numerator and denominator by the same non-zero quantity. Okay? It is not true, however, that a plus k over b plus k. Okay? This is not equal to a over b. We cannot just cancel the k's here. Okay, so we must first get everything joined by multiplication, that is factors. Canceling is a type of division, so first we have to have things joined by multiplication. So the idea is to factor completely the numerator and the denominator. In the numerator, we notice that there is a common factor to these two terms, namely 2x. We can pull out a 2x, leaving us with x minus 3. This gives us 2x squared minus 6x when we multiply by the distributive law to check. The denominator, we have no factors in common, but we do have a trinomial which can be factored into two binomials. We are looking for two numbers which multiply to plus 9 and add to minus 6, and of course they are minus 3 and minus 3, giving us, checking by FOIL, x squared minus 3x minus 3x minus 6x plus 9. We now have something in the form, say, ak over bk. And we can divide numerator and denominator by x minus 3, cancel the x minus 3's, giving us a final answer of 2x over x minus 3. And that's as far as we go in this problem. We cannot cancel the x's. X is a factor upstairs, but it is a term downstairs, not a factor. In the following example, we'd like you to perform the indicated operations and simplify. We have x squared minus 3x minus 10 over 3x squared times this fraction times 5x over x squared minus 10x plus 25. Okay, now while when you multiply fractions, you can multiply the numerators and divide by the product of the denominators. It is helpful if we can sort of reduce before we do this. Okay, we're looking to see if we can factor everything out, and maybe there'll be factors in common in the numerator and denominator that we can cancel out. Okay, we have the 5x here and the 3x squared here. This trinomial, x squared minus 3x minus 10, can be factored into two binomials. We are looking for two numbers which multiply to minus 10 and add to minus 3. They are minus 5 and plus 2, giving us x squared plus 2x minus 5x minus 3x minus 10. And similarly down here, we're looking for two numbers which multiply to plus 25 and add to minus 10. And they are minus 5 and minus 5. So we can see that x minus 5 is a factor here in the numerator and in the denominator. And since, of course, we can multiply the numerators and put that over the product of the denominators, we are permitted to cancel, say, a factor in the numerator here with a factor in the denominator here. Any factor in either of the numerators can cancel any factor in either of the denominators. Okay, we see also that x is a factor in common in this numerator and in this denominator here. If you think of 3x squared as, say, 3x times x, we can cancel one of the x's. And let's see what's left. Okay, that leaves us with a final answer of Upstairs we have 5 times x plus 2. And downstairs we have 3x times x minus 5. In our next example, we have x cubed y minus xy cubed divided by x squared y squared. This fraction to be divided by 3x plus 3y. Now we know that when we divide fractions, we can invert and multiply. Okay. Remember that although this doesn't look like a fraction, we can think of it as 3x plus 3y over 1. So it is one fraction divided by another, so this can be rewritten in the following form. X cubed y minus xy cubed over x squared y squared times inverting the second fraction here and multiplying. We now have it in a problem similar to, we have a problem similar to the last one, and we're going to factor each numerator and denominator completely and see if we can cancel out any factors. Okay. The 3x plus 3y down here, we can factor out a 3, leaving us with x plus y. X squared y squared is simply xy times xy. We just leave it like that. Now, over here, we do have a common factor for these two terms. Let's see what we can take out. We can take out an xy, and if we do take out an xy, we are left with, in the first term, an x squared, and in the second term, a y squared. Multiplying this out, we get x cubed y minus xy cubed. Now, x squared minus y squared itself can be factored. Again, it's a difference of two squares, and we can factor that and get x plus y times x minus y. X squared y squared. Since I noticed the xy upstairs, let me write this as xy times xy. X squared y squared is xy times xy. Now let's see what can be canceled out. Xy is certainly a factor upstairs and downstairs, and so is x plus y. Leaving us with a final answer of, upstairs we have just x minus y left, and downstairs x times y times 3, or 3xy. And that's as far as we can go in this problem. The x is a term upstairs and a factor downstairs. We cannot cancel out the x or the y for that reason. Okay, we've seen some examples with multiplication and division of fractions, and now let's work with addition and subtraction of fractions. We would like to perform the indicated operations here. 2x plus 5 over 3x plus 6 minus x minus 4 over 3x plus 6 plus 5x minus 9 over 3x plus 6. Okay, the trick when adding and subtracting fractions is that we have to have the same denominator. If we have the same denominator, we can simply combine the numerators over the common denominator. This is a fairly simple problem in that these fractions all have the same denominator, so let's combine the numerators. Now, when you're combining numerators, addition doesn't cause any problem, but subtraction might, because we have to take away x minus 4, and when it's more than one term, we have to use parentheses, because it's minus in parentheses x minus 4. With the addition, you don't have to put the parentheses, because it's implied. But I guess it's safer just to simply put the parentheses in each case, and then you won't make a mistake. This numerator minus this numerator plus this numerator all over the common denominator. Now, we would like to simplify the numerator. We have 2x plus 5 This minus before the x minus 4 is like a minus 1 to be distributed. So we have minus 1x. Minus 1 times minus 4 is plus 4. Plus 5x minus 9. Denominator is still 3x plus 6. Upstairs, let's collect the like terms. We have a 2x, a minus x, and a plus 5x. 2x minus 1x gives us 1x, plus 5x gives us 6x. Plus 5 plus 4, that's 9, minus 9 gives us 0. So we have 6x over 3x plus 6. We'd like to put this into simplest terms. Lowest terms, we want to reduce this. You just don't cancel out the 6's, okay, because 6 is not a factor downstairs. But what you can do is factor the numerator and the denominator. The denominator, you can pull a 3 out. It's a common factor for the two terms, leaving us with 3 times x plus 2. In the numerator, 3 is also a factor, leaving us with 2x. And we have our like ak over bk. We can cancel the 3's here, leaving us with 2x over x plus 2. And this is as far as we can go on this one. I just want to mention on this problem that we were adding and subtracting fractions. Don't confuse this with fractional equations. We'll be doing them later on in this tape in fractional equations. You might remember from earlier videotapes, we multiply both sides by the LCD and we clear fractions. Okay, and we work out an equation that does not involve fractions. Here, however, when you just add and subtract fractions, you do not lose the denominator. Your final problem, you still have a fraction here, your final answer. Okay, in our next example, we also want to add and subtract fractions. However, this time, we are not that lucky in that the denominators are not all the same to start off with. Two over 5x squared y minus 5 over 6xy cubed plus 1 over 4xy squared. In the last problem, they all had the same denominator, so we simply combine the numerators over the common denominator. Here we have another step that comes first. We have to build fractions equivalent to each of these, and they should all have the same denominator, so then we can combine numerators over the common denominator. And the question becomes, what should be this common denominator that we're going to combine over? We're looking for the LCD, the lowest common denominator. Let us look at each of the denominators that we have. 5x squared y, 6xy cubed, 4xy squared. We factor each denominator completely. 5xxy, 6, 2 times 3xyy, 4, taking it down to its prime factors, 2 times 2xyy. And to get the LCD, well, 5 appears once here, not here, and not here, so we take it once. 2 appears once here, but twice here. No times here. We take it, therefore, twice. We don't take it a total of 3 times. It's not the total number of times it appears anywhere, but rather the greatest number of times it appears in any one denominator. X appears once, twice, so we'll need 2 of them. And Y appears once, 3 times, twice, so we'll need 3 of them. So the LCD becomes, and 3 appears not here, once here, and not here, so we'll need 3. Let me squeeze it in here. So we get 3 times 5, 15 times 4, 60 x squared y cubed for the LCD. That's sort of the smallest quantity, such that each of these denominators will go evenly into it, or each of these denominators will be a factor of that. So we want to build fractions equivalent to each of the original fractions, each having the denominator 60x squared y cubed. And using the fundamental principle of fractions, in each case we're going to have to ask ourselves, What did we multiply the denominator by to get this denominator, and then we multiply the numerator by the same quantity? Okay, we get an equivalent fraction by multiplying the numerator and the denominator by the same quantity. Okay, well, to go from 5 to 60, we had to multiply by 12. X squared we have in both, and y to y cubed, we need a y squared. So to go from this denominator to this denominator, we'd have to multiply by 12y squared. Therefore, the numerator must be multiplied by that quantity as well. Now let's look from here to here. To go from this denominator to this one, we'd have to multiply by 10 to get to 60. X, just 10x. So we multiply the numerator by that. And then finally, to go from 4 to 60, we'd have to multiply by 15. To go from x to x squared, we multiply by x, and y squared to y cubed, we have to multiply by y. We now have three fractions with the same denominator. We would like to subtract and add like this. We can combine the numerators over the common denominator. We get 2 times 12y squared, or 24y squared, minus 50x plus 15xy. And here we have our answer. Okay, in our next example, we once again want to work with subtract fractions. 5 over 2x, take away 3 over x plus 2. The LCD in this example is simply the product of the two denominators, 2x times x plus 2. You need both of the denominators here. So we're going to build fractions equivalent to the original ones, having denominator 2x times x plus 2. Once again, we will ask ourselves, what did you multiply this denominator by to get this? You multiplied it by x plus 2. So let us multiply the numerator by x plus 2 as well. And what did you get? What did you multiply this denominator by to get this? You multiplied by 2x, so multiply the numerator by 2x also. Now we have two fractions with the same denominator. And we will combine the numerators. 5 times x plus 2 minus 3 times 2x, giving us 5x plus 10, distributing the 5 through the parentheses, minus 6x over 2x times x plus 2, for a final answer of, let's see, we have 10, 5x minus 6x, that's minus 1x, 10 minus x over 2x times x plus 2. By the way, on this problem, it would have been perfectly okay to say 5x minus 6x is minus x plus 10. Minus x plus 10 is the same as 10 minus x. So you could write your answer in either way. 8 over x squared plus 2x minus 3 minus 6 over x squared plus 3x. Now, this denominator, factors, you can pull out an x, giving you x times x plus 3. And this denominator also factors, this time, though, into two binomials, looking for two numbers which multiply to minus 3 and add to plus 2. They are plus 3 and minus 1. Okay, you don't take the product of the denominators. All we're going to do for the LCD is take each factor the greatest number of times it appears in any one denominator. X plus 3 appears once here and once here, so you only need it once. X minus 1 appears once and no time, so you need it once. And x does not appear here, appears here once, so you need that. So the LCD is x times x plus 3 times x minus 1. Just reminding you, in the problem that we just worked out, okay, taking each factor the largest number of times it appears in any one denominator, 2x and x plus 2 are the three factors. 2 appears in here, but not in here as a factor, so we take it only once. X appears in here as a factor, but not in here as a factor, so we take it once. X plus 2 here is a factor, but not here. So we needed the 2, the x, and the x plus 2. Don't confuse it and think that 2 appears here and here, and you have to take it twice, or that x appears here and here. Here, 2 is a factor, x is a factor, and x plus 2, the whole thing, is a factor. Okay. Going back to this problem, okay, we have our LCD. We're going to build fractions equivalent to the original ones with the same denominator. We know that this is the denominator, so we would like to build fractions equivalent to the original one, having this new denominator, namely x plus 3, x minus 1 times x. X plus 3, x minus 1 times x. This is the LCD. Okay, we would like two fractions equivalent to the original ones having the same denominator. Okay, we can erase that now. This is, okay, now we ask ourselves, what did we, okay, these are the denominators rewritten in the factored form. What do we multiply this denominator by to get this? We have the x plus 3, the x minus 1. The only thing we needed was the x, so we multiply the numerator by x as well. And then we say, what did we multiply the denominator here by to get this denominator? We have the x plus 3, we needed the x minus 1, therefore the numerator gets multiplied by x minus 1 as well. Okay, now we have two fractions with the same denominator. We can combine the numerators, giving us 8x minus 6 times x minus 1, all over the common denominator, x plus 3, x minus 1 times x. Combine the numerators over the common denominator. Okay, let me just rewrite that over here. We'll see what we are. We have 8x minus 6 times x minus 1 over x plus 3, x minus 1 times x. Now we will distribute the minus 6 through the parentheses. 8x minus 6x, minus 6 times minus 1 is plus 6, over x plus 3, x minus 1 times x. Now, on top, 8x minus 6x, that's 2x, plus 6, combining like terms, over x plus 3, x minus 1 times x. And then last, we have to ask ourselves, is it in lowest terms? Are there any factors in common in the numerator and the denominator? And we notice that if we pull out a 2 on top, we factor out a 2 on top, we'd be left with x plus 3. And x plus 3 is a factor downstairs as well, so that we can simplify some. We can cancel out the x plus 3's, leaving us with 2 over x minus 1 times x, or 2 over x times x minus 1, either way. You can write x minus 1 times x or x times x minus 1. In the next example, we would like to simplify the following. 2 minus 3 over x divided by 2 minus 1 over x minus 3 over x squared. In a sense, we have like to subtract these fractions, combine these fractions. We get a fraction here, and then divide the two fractions, which means to invert and multiply. So it's sort of a review of everything we've done so far. Okay, let's work out the numerator separate from the denominator. In the numerator, we can think of this as, say, 2 over 1 minus 3 over x. If we want to find the LCD in the numerator, okay, it's going to be 1 times x, or just x. So we build fractions equivalent to the original ones, each having the denominator x. The 3 over x were all set. Here, we'd have to multiply the denominator by x, so we'd multiply the numerator by x as well. So that is, we've replaced 2 by 2x over x, which it's equivalent to. But now it has the same denominator as this term here. Okay, now in the denominator of the problem, we have 3 little fractions. Think of this as 2 over 1. The LCD for these, 1x and x squared, would be x squared. We want 3 fractions all having the denominator x squared. The 3 over x squared we already have. To go from this denominator x to this denominator x squared, we multiply by x, so we multiply the numerator by x as well. And then here, to get from this denominator to this one, we multiply by x squared, so we multiply the numerator by x squared as well. We now have 2 fractions upstairs having the same denominator. We can combine over that denominator, giving us 2x minus 3 over x. And downstairs, 3 fractions with the same denominator. We can combine numerators and put it over the All right, now to divide fractions like this, we know we're going to invert and multiply. So let's see. Continuing this over here, we have 2x minus 3 over x. Instead of dividing by this fraction, we now invert and multiply by the one downstairs, giving us x squared over 2x squared minus x minus 3. This fraction divided by this fraction doesn't matter if we have it with the slash or if we had it with the division symbol like that, the way we had earlier. It still means we invert and multiply by either the one in the bottom or the second fraction. And that's exactly what we've done here. Okay, and now we look to see if we can factor these numerators and denominators completely. This is x. X squared is x times x. This is 2x minus 3. And with a little work, you can factor this trinomial into 2 binomials, 2x and x. A little bit of trial and error, and you're able to put in a minus 3 and a plus 1, giving you 2x squared plus 2x minus 3x minus x minus 3. The 2x minus 3 cancels this. One of the x's cancels, giving us a final answer of x over x plus 1. By the way, this is called a complex fraction in that, okay, we have fractions in the numerator and or also in the or the denominator. Okay, when you have fraction, you have a fraction, and as well you have fractions in the numerator or the denominator. It's called a complex fraction, and this is one method of solving this problem. Okay, if you go back